going to add on a couple of things about this chapter. So I'll just start over again. Okay, so now we're going to see, I'll use a new word, find the roots. I know it's a weird word for math, but that's what it sort of means. The zeros are sort of how the graph comes out from, like a root, like a fruit of a flower. All right, so I have negative 20 x squared plus 2x equals negative 6. So number one, we have to get it equal to 0. So I'm going to add 6. I'm not even going to show it. If you find I know a lot of you can do this without showing all the work. So if you find you need me to show the steps, tell me I need to show the steps. But I'm hoping by now you can, not that you should skip steps, but you don't have to show every single tiny step. All right, now we have an issue. I have a negative in the front. So I know I got to factor a negative out. Can I factor anything else out? Well, 22 and 6, I can divide by 2. And I can't take x's out because 6 doesn't have an x. So we're going to factor out negative 2. That means I'm dividing everything by negative 2. Yes, negative 2. Negative 2. And I get negative 20 divided by negative 2 is 10x squared. 2 divided by negative 2 is negative 1x or negative x. And 6 divided by negative 2 is minus 3, and it's equal to 0. Now, like before, since we had this negative 2 in the front, I highly suggest you set it up so you don't forget the negative 2. All right, so these numbers aren't so bad. So we're going to try without the AC method. 3 and 1, a 3 can only be 3 and 1. So I know that. 1 was 3, 1 was 1. It has to be. 10, I'm going to guess is 5 and 2. We need a negative 1 in the middle. If I put the 5 here, that's 5 times 1 is 6. That means this had to be 2. Before I even put the x's in, I want to see if it's going to work. So this means this would be 5. This would be 6. Now I need a negative x. So if I make this a negative, I think I got it. X plus. I'm trying to show you how I think through a problem sometimes. Okay, so let's check. 5x, negative 6x, that's negative x. Perfect. Perfect. Now, this one's going to have something different happen, but always set every single thing equals 0. Negative 2 equals 0. 5x minus 3 equals 0. 2x plus 1 equals 0. And then you're going to go, wait, negative 2 never equals 0, does it? No. So that doesn't count. That's like a fake answer, not happening. Why did we have an answer last time? Because we had an x in the front, different. This is just a number. So negative 2 can't equal 0 ever. So that's not even an answer. We are going to now add 3. 5x is equal to 3, and then we're going to divide by 5. So one of my answers is 3/5. And my other answer, I'm going to subtract 1. 2x equals negative 1, divide by 2, x is equal to negative 1/2. So my two answers were 3/5 and negative 1/2. Now I have a question for you. Go back and look at those last few problems we did and tell me if you can find something, how will you know when you have 2 answers or 3 answers or even 4 answers? How do you know? You can know. Look back at the problems I gave you. Just take like a minute. Look back at the problems I gave you. Don't base, if someone knows it, don't say it yet. Go back to the last few problems I gave you. Okay, hold on. Let me just finish what I'm saying. All right. So go back to the problems I gave you, look at the problems I gave you, look at the ones that had 3 answers and the one that had 2 answers, and why do you think? And then just think about it. Okay, now I'll take the question.
Okay, so when I was looking over what I did and what you did, I did it a little bit differently, and I got the 2x minus 3 and the 5x plus 1. So
2x
I
minus
think
3.
I saw how I got that, but
Yeah, that's because,
essentially when you factor it back.
yeah, because that's why I checked, this is why I checked that at the end, because this will give you 2x and this will give you negative 15x. And if you put them together, you got negative 13x, and you were looking for a negative x. So you're
That's
not
what I meant.
wrong. You just have to rearrange it. That's all. I mean, it is wrong, but you just have to rearrange it so you get the right thing in the middle. Okay. All right, anybody know how to tell when you're gonna have one answer? Not one answer. We're gonna have 2 answers or 3 answers? Anybody know? Okay, let's try this one. Maybe this will tell you. So this last problem, we had 2 answers, right? So let's look at another one, 2. Negative 16x to the third plus 36x equals 0. Okay, again, I have a negative. Can't have a negative in front. Negative's got to come out. But 16 and 36, I can definitely do something with that. What can I factor out? 4. But I also have x's on both terms. So the smallest exponent is the 1. So I can factor out a negative 4x. And by the way, if you factor out and realize you could do more, just erase it and go back. Here we go. Okay, so we're going to divide everything by negative 4x. Negative 4x. So when I divide negative 16 divided by negative 4, I get 4. X cubed divided by x, x squared. 36 divided by negative 4, that's negative 9 or minus 9, and x goes away, equals 0. But look at this. Perfect square, difference of perfect squares. I can factor more. Negative 4x. Okay, so 2 times 2 is 4. X times x is x squared, and 3 times 3 is 9. All I have to do is figure out my signs. I don't have a middle x, so it had to be one positive and one negative. Set each part equal to 0. Negative 4x equals 0. 2x plus 3 is equal to 0. 2x minus 3 is equal to 0. All right, first one, divide by negative 4. I get x is equal to 0. That's 1. I'm going to subtract 3. 2x equals negative 3. Divide by 2. X equals negative 3 halves. That's my second one. I'm going to add 3 this time. 2x is equal to 3. Divide by 2. X is 3 halves. So this time, yeah, Amber, you're right. You're right. This time I had 3 answers. So one of you figured it out. What's the difference between the first one that had 2 answers and the second one that had 3 answers? There's something in the equation that makes it different.
The power.
It's the power. Yes, it is. So if you have a square and it's factorable, you will have, again, I have to say factorable because some of them aren't factorable. If it's a square and it's factorable, you will have 2 solutions. If it's a cube and it's factorable, you will have 3 solutions. This is a way to check if you got everything, right? So if I do a cube and I only have 2 answers and it's factorable, I know I forgot something somewhere, and it's probably the 0. So you can check yourself. Now, this is not true for every cube because not everything is factorable, but if it's factorable, I know it's yeah, some people have been sending me messages about the internet going in and out. If you pop out, just pop back on and I'll put you that in, and it's the weather. I know it is. Sorry too. I don't know if it could be me too. Maybe I'm popping in and out. It's really bad right now outside. So highest exponent degree tells you how many solutions if it's factorable. Okay, I want to do one more, and actually I want you guys to do it. 3. I want you guys to try it. Okay, so we are finding the roots of this equation. 6x squared plus x minus 12 is equal to 0. Okay, I'm gonna just sit here for a minute. Give it a try, see if you can find the 0. How many answers should it have? Give it a try. Mm-hmm. Okay, I'll start doing it. If you're still working, I'll work on it.
Does it matter what order we have our answers in?
Nope, doesn't matter. Doesn't matter.
Okay.
It's a good question too. I love it. 3x, 2x, 4 and 3. Let's see. Plus 9 minus 8. That should be the factoring part. And then 3x minus 4 is equal to 0. 2x plus 3 equals 0. Add 4. 3x equals 4. X equals 4. Okay. All right, do we get it? Good, yeah, I see some good saying, I see fingers up. I see question, any questions, ask me. I see faces that look that great. I see faces that are like, oh yeah, I got this, I'm fine. Question, question, question.
Okay, so honestly, I didn't get that, but I don't really know where I went wrong. So
Okay, you know where you went wrong?
I got to the point where I got 2 times 3x squared plus x minus 6 equals 0. And then I did 2, I factored out 2, and then I was trying to find the numbers or whatever, but then I just stopped there because like I don't know, I don't get it.
You try to pack, do you say you factored out too? Did you factor out something first?
No, I don't know, I don't get this.
It just takes a lot of practice, a lot of practice, a lot of practice. It has to do with the numbers and figuring out how the numbers work together. I can sit here for 3 hours and do problem after problem. You're still not going to get it till you practice. It's like a bike. Get on a bike, you fall down, and then it takes that much practice to get there. It's all I can say is practice. I'm not saying it's easy. It's not easy, but it takes a lot of practice. And once you practice enough, the numbers sort of kind of, you start seeing it. The reason this had to go this way is because 3 times 3 is 9. And -4 times 2 was -8. And that will give you your -1. So you couldn't use like 6 and 2 because that won't give you your +1 in the middle. So it's a combination of what makes that this and then what makes that by adding. It just takes a lot of practice. I was hoping you guys would practice a lot this weekend because you had the time, but that's the time to practice after we did it once. But practice, practice, practice. And it's one of those skills you can't let go. Like you have to know how to do this as you go forward. Okay, so real life problems. So how do you use this in real life problems? Well, I got 2 for you. All right. Okay, a model rocket is launched from the ground. Oh, by the way, too, I go to school to teach a class, and I'm right across the hall from the tutoring center, and they are not busy at all, and they want people to come. So if you're really having trouble with this, go to the tutoring center. They're more than willing to help you. That's what they're there for. Maybe they can show you a different way other than what I showed you, what might make more sense, but factoring really comes down to practice. A model is launched from the ground. Its height, h in feet, at time t is approximated by this equation. I write the equation out. H equals -16 t squared plus 112 t. So they found the equation for the model, how it launches. All right, so then tell do yet. This is what we have to do. We have to find how long it takes the rocket to return to the ground. Or if you want to think of it, land. How long does it take the rocket when you shoot off? How long does it take to land? Come down all the way. Quadratic equations, it's quadratic because it's square. Quadratic equations are great for word problems because say you're a soccer player, you hit a ball, right? So you're hitting a ball here and it lands here. You can figure out what it is. You know why? Because that's your x-intercepts from the ground. Think of the ground like the x-intercepts, right? So this is the same thing. You have a rocket, it's shooting up in the air and it's going to hit the ground. They want to know where, how long it takes to hit the ground. That's my question mark. How long? Well, that means we need the x-intercepts. We need to know the roots or the x-intercepts. How do you find that? By factoring. All right, so I'm going to write the equation again down here. It says in front of all of us. So H is equal to negative 16 t squared plus 112 t. Okay, we are going to H. Now, listen to me. Listen, when it hits the ground, what's the height of the rocket? 0, right?
0.
0. It has no height. So this is going to be 0, which sets us up right for factoring and solving. Perfect. And honestly, I don't like it that way, so I'm going to turn it around. You don't have to do this. Okay, so factoring. Can we factor anything out? Sure we can. At least a t and a negative. We got to take the negative out. We got a t, but I think we also have a number. I think it's 16. Yes, we can take 16 out too. 112 is 16 times 7. So, boom. We're dividing everything by negative 16t, negative 16t. Okay, negative 16 divided by 16 is 1. T squared divided by t is t minus, I just told you that it's 7 and the t's are going to cancel and it's equal to 0. I have to set each of them equal to 0. Negative 16t is equal to 0. T minus 7 is equal to 0. Divide by negative 16, divide by negative 16. T is equal to 0. I can add 7 and I get t equals 7. Now it's quadratic, so we did get 2 answers, which we should, but one of them makes absolutely no sense. And this is what happens with quadratics and real problems. You got to think about, does the answer make sense? Would does the answer be time is 0? No, it means it didn't even go off, right? At time 0, it still started. It hasn't even started yet. So the answer has to be 7. So a word problem always ends in words. It took the rocket 7 seconds to hit the ground. So another example, let's say we got a negative answer. Time isn't negative, so that would also be a false answer. So when you do real world problems, sometimes the answers that you get are answers. They also make sense to the problem that was given to you. So you have to think about what the answer means. So rockets and balls or footballs or anything that goes in like an arch kind of shape is going to be something quadratic that you could solve this. The other one I want to talk about for a real world problem is the Pythagorean theorem. I don't know how long it's been since you've seen the Pythagorean theorem, but it can only be used on right triangles. It can only be used for right triangles. So if you don't have a right triangle, meaning that one of the angles is 90, you can't use Pythagorean theorem. And just sort of review what it means to be the Pythagorean theorem, where it came from. So we'll call this A, we'll call this B, we'll call this C. So Pythagorean theorem is a relationship of the sides of a right triangle. And it says that if you take the two legs and square them and add them together, A squared plus B squared, they're your two legs. It has to be equal to the hypotenuse squared. So A squared plus B squared equals C squared. If I take the two legs of my right triangle and I square them and add them together, it'll be equal to the square of my hypotenuse. And the hypotenuse is the longest side of your triangle and it's opposite the right angle. That's your hypotenuse. So for instance, let's say, we're just going to do regular numbers before we do what we're doing. Let's say I have 3 and 4, and I want to know what my hypotenuse is. They're my two legs. So I would do, doesn't matter which one you make, A or B, but I do 4 squared plus 3 squared has to be equal to C squared. If I square both legs and add them together, it has to be equal to the square of the hypotenuse. So 16 plus 9 has to equal C squared. 16 plus 9 is 25 is equal to C squared. Now, in order to get rid of a square, you square root both sides. So C had to be 5. So I just found that this C is 5, and my triangle is a 3, 4, 5 triangle. We don't have to do that just for numbers. We can use it in a real world problem. And that's what I'm going to go to now. But that's the overview of the Pythagorean theorem. All right, here's my problem. Find the length of the shorter leg. That means the leg that's not the hypotenuse, but it's the shortest leg of a right triangle. If the longer leg is 10 miles more than the shorter leg. And the hypotenuse is 10 miles less than twice the shorter leg. Sounds like a lot. We got to break it down to pieces. Okay, find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than a shorter leg, and the hypotenuse is 10 miles less than twice the shorter leg. I drew it purposely to make one look like shorter than the other. So this is going to be my shorter leg. And this is going to be my longer leg. And this is my hypotenuse. Just so we keep it all straight, which one's what. Okay, so they just tell us how they compare, right? So when you compare, you're writing an expression. So let's just look at the first one. The longer leg is 10 miles more than the shorter leg. All right, when that happens, you make whatever you're comparing to your X. So the longer leg is compared to the shorter leg. So Rick is shorter leg X. The longer leg is 10 miles more than the shorter leg. So you could do 10 plus X or X plus 10. Usually I put the X first. So I took the shorter leg and I'm adding 10 miles. The longer leg is 10 miles more than the shorter leg. So the shorter leg is X. The longer leg has to be X plus 10. Now let's look at the other one. The hypotenuse is 10 miles less than twice the shorter leg. I know it has a minus 10. Twice the shorter leg, 2 times the shorter leg. It's 2 times the shorter leg minus 10. We have to find, the original question is, original thing they're asking you to do is find the length of the shorter side. So we have to find X because shorter side is X. What are we going to do? We're going to use Pythagorean theorem to set up an equation, and then we're going to solve for X. So our Pythagorean theorem is a squared plus b squared equals c squared. This is a quite detailed equation. So we don't have A, B, and C. We did X's, right? So let's make this A, we'll make this B. This one has to be C. A and B could be reversed, but C has to be the hypotenuse. So we have X squared, that's for the shorter side, plus the longer side in parentheses, X plus 10 squared is equal to, the hypotenuse is 2x minus 10 squared, so parentheses, 2x minus 10, the whole thing is squared. Now it's a lot of math. Remembering that square means 2. So I'm going to rewrite it so that I have it all written out. That's what it means. Okay, so now we have x squared plus, now I'm just going to double distribute, FOIL it. So x times x as x squared. 10 times x is 10x. 10 times x is another 10x. And 10 times 10 is 100. I just FOIL that one side. Equals. And now we're going to FOIL the right side. 2x times 2x, 4x squared, 2x times negative 10, negative 20x, negative 10 times 2x, another negative 20x, and negative times on negative, sorry, negative 10 times negative 10 is 100. Whew. All right, so what I see is that we have a big mess that we need to simplify. So we need to combine like terms. So I can put these x squares together and make 2x squared. I can also put these 10 x's together and make 20x plus 100. And now we're going to clean up the other side because you really want to make sure all the like terms are combined before you do too much. So I have 4x squared. I can combine my -20 and -20 is -40x. And then I have plus 100. Now it is getting everything on one side equal to 0 because we're going to have to factor it. Because the 4 is on the right side, I'm going to subtract 2x squared to keep it a positive x squared. So I don't have to factor out a negative. So I'm going to move everything to the right. 20x plus 100 is equal to 2x squared minus 40x plus 100. Now I got my x squares over here on this side. This is the side I'm going to. I have my x squares over here, and now I need to get my x's together. So I'll subtract 20x, subtract 20x. Notice how I line them up under each other so that I don't add it to the wrong thing or subtract it to the wrong thing. So I have 100 is equal to 2x squared. That would be -40 minus 20, -60x plus 100. Ooh, one more thing we gotta move, 100. Okay, -100, -100. It actually made our problem a little easier, actually, because we have 0 is equal to 2x squared minus 60x. The hundreds canceled. We don't have any numbers left, any constants left. Okay, just because I don't like it on that side, I'm gonna rewrite it and switch the sides. You don't have to do this at all. All right, I can factor stuff out. I see 2, and I see they both have an x. We're going to factor 2x out, and let's see what we're left with. 2x, 2x. Okay, that leaves us an x. -60 divided by 2 is -30. X cancels. Equals 0. We're almost there. Whew. Okay, so that each of them equal to 0. 2x is equal to 0. X minus 30 is equal to 0. And now we can solve. Divide by 2, divide by 2. X is equal to 0. X is equal to 30. Of course, we got 2 solutions because it was a square, right? All right, but again, this is like a real world problem. It's a word problem. So would I have 2 answers? Probably not. Which answer doesn't make sense? 0. If I have 0, nothing's happening, right? That means the side is 0. Is the side of my triangle 0? I don't think so. They didn't tell us it was 0. If I make it 0, I don't have a triangle. So my answer is 30. So X is 30. Now they wanted to know what the shorter leg was. The shorter leg is, and just remind you where we are, go back to your picture and you'll see that the shorter leg is X. So my shorter leg is 30 miles because they gave us miles, 30 miles. If they ask you for the longer leg, you would have to plug 30 into X plus 10 and make it 40. If they ask you for the length of the hypotenuse, you would have to plug 30 into the hypotenuse expression, 2 times 30 minus 10, and then that would be 50. So really pay attention to what they're asking you in the problem to find out what answer they want. All right, one more thing for this section. That's a long one. Very doable, though. It just takes a little bit long. And you just be a little careful with your numbers. Last thing. It's like a matching. So I got to draw some pictures first. We're going to match each function with its graph. Okay, so let me draw these first. So this would be A, B, C. It's three equations.
I was kind of hoping we were done with graphs after the last.
No, they'll never be done with graphs ever, ever.
Yeah, not a fan of this. The
Yeah,
graphs. I don't care
yeah.
about the word problem. I don't even care about all the X's and the Y's, but these graphs, man.
Yeah, you'll never be done with graphs. Graphs will be with you forever. Wait till your college algebra class. I think there's a lot of graphs in there. This is where you really learn about how the graphs and everything's connected. All right, so let's see, did I do that right? Yes, okay, so, okay, well, I totally missed that one. Okay, and then my last graph, I might have to put it on the bottom. I am, I'm gonna put it on the bottom so I can fit them all on one page, hold on. There you go, see, and I'll put the equation next to it. I see. Okay, I'll just sit and wait for you guys before I write the equations down. This is the one bad thing being online. If you're in a classroom, I can hand you out a worksheet while the graphs are already done. But that's all right. It's good because it gets you like to draw it, and I hope you're thinking about it as you're drawing it. Okay, nobody share the answers. As soon as I put the equations down, you can match them if you can, but don't give it away. Okay, so you're just gonna put next to the equation which letter it is. All right, so first equation. All right, there's the three equations. Take a minute or two, look at the equations and see if you can match them. Amber, you're right. Yep. Okay, you ready? Okay, the first one is B. Because this is at x equals 3, and this is at x equals -1, and there's only two of them, two parentheses, two of them. Okay, next one is A. And that's because this is at x equals 5. This is at x, equals 1. And this is at x equals -1. Now remember, you're saying them equal to 0, right? So you would do x minus 5 equals 0, x minus 1 equals 0, x plus 1 equals 0. And that's how you get 5, 1, and -1. And of course, then the last one has to be C. And that's because you have 3 zeros, x equals -1, x equals 0, and x is equal to 1. How we do? Not too bad, right? Yeah, I see some of you guys had it. Good. Excellent. Excellent, excellent. All right, that's the end of 5-8. What I do want to do, we don't have much time left, which is good, because I don't want to do that much, but I do want to set up for what we're doing in the last class, because the last class we have 2 big topics to do. So I want to at least get it set up in your mind. Any questions on this before I go? All right, so I am going to just introduce us. That's it. (6.2) introduction. And it's about adding and subtracting rational expressions. So we're not solving for anything for these, at least right now. We're just adding and subtracting expressions. It's like adding and subtracting fractions, except with algebra. Okay, right now, we're only looking at ones with common denominators. So we're looking at ones with common denominators. And if you can think fraction, how you do a fraction, it's done the same way. It just looks different. That's all. Okay, so we want to add. Number 1, add. This is a rational expression. 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. I notice both denominators are exactly the same. So we can add them. How do we add them? Well, when you add fractions, just number fractions, you add the top and you keep the denominator, right? So we are just going to keep the denominator, 7p, 2p plus 7, and we're going to add the top. So we're going to do 4p minus 3 plus 3p plus 8 and combine our like terms. If I combine my like terms, 2p plus 7 again just stays. I have 4p and 3p, which is 7p, and -3 plus 8 is 5. And that is my final answer. You cannot simplify this. Well, you can, but not this problem. We'll get to simplifying in a minute, but this one cannot be simplified. Do not think that you can cancel p's out. You can cancel 7 out. So you can't. The only time you can simplify a fraction, well, this kind of fraction, is if it's being multiplied. These are not being multiplied, being added. So nothing cancels, nothing simplifies. That is the answer. 2. This time we're going to subtract. Eight y over y minus 2 minus 16 over y minus 2. Again, we have common denominators. So we don't have to worry about getting common denominators. We can just subtract across. So just like a regular problem, regular fraction, I keep my denominator and I subtract my numerator. Now we have a new issue. Not an issue, but we can simplify this. I thought we couldn't simplify this. Well, the first one we couldn't because we couldn't factor anything out. Look at the numerator. Can't I factor an 8 out? I think I can. So if I take 8 out, what am I left with? I'm left with 8y divided by 8 is y minus 16 divided by 8 is 2. Now these are being multiplied, right? There's a multiply sign between 8 and y minus 2. So guess what? Now, because they're being multiplied, 8's being multiplied by y minus 2, and they are identical, I can simplify it. And my answer is going to be 8. You have to have multiplying to simplify. Because they're identical, they will cancel. Here's a difference. Let's say I had a y minus 2 over y minus 2. Okay, I can't do this. Nope. No. Okay, because it's not being multiplied. Well, that's would be a y over y minus 2. What I can do is factor out something. I can factor a 2 out. And what am I left with? 8 divided by 2 is 4y minus 1. And then I have y minus 2. Can I simplify these two? No, they're not identical. So this time that would be my answer. So you want to think factor. Again, we're back to factoring. Can I factor anything out? After I factor out, can I simplify? If you can't factor, you can't simplify. Just like that. I have one more, and then we're going to call it a night. 3. I hope your question is, okay, what do we do if they're not the same denominator? Well, that's what we're going to do next time. You have to get common denominators, just like a fraction. All right, 3y over y squared plus 3y minus 10 minus 6 over y squared plus 3y minus 10 equals. So we're subtracting. I should put subtract. I forgot. Subtract, although you can tell what we're doing. Number 1, if you can factor, you factor first. I know they're common denominators, but I need to see if I can factor them. And I'm going to change them to be factored if I can. So let's see. Can I factor them? 1, 2, 1, 2, y. Okay, 2 numbers are multiplied to be 10, but will add up to be 3. One's negative, one's positive. That'll be 5 and 2, right? Plus 5 minus 2. You always factor them if you can factor, especially the denominator. Always, well, only the denominator. Hold on a second. Do not factor numerator because we have to add, but the denominator, always factor it if you can. So it can be factored, and you're going to see why you need to factor it in a second. Hey, now I'm just going to write the same numerator. They're still the same denominator. I just change it to be factored. Okay, equals. So this stays the same. And I'm going to subtract 3y minus 6. And then I have to ask myself, can I factor anything? And the answer is yes. I have a 3 and a 6. So I can factor a 2 out. Sorry, 2 out. No, 3 out. 3 I could take out. So that leaves y minus 2 over y plus 5 over y minus 2. And you see why we had to factor the denominator? Because I'm multiplying and I'm multiplying, and if I'm multiplying, I can simplify. Equals 3 over y plus 5. And that's all I'm going to do, with a little tiny introduction, because when we come back, we're not going to have the same denominator, and we have to make the same denominator, and everything else is going to be the